Hey guys, we're back. We're finishing up 9.4, which is on series and sequences. We did all about sequences to begin with, and now we're going to talk about series. So if you do not know anything about sequences, go back and watch the first part of this lesson. So let's start off with some vocab. Series is referring to the sum of the terms in a sequence. Okay, so if we think about an example of this, so if I think of an example, I have a sequence and that's referring to a list of numbers, 4, 7, 10, 3, etc. If I'm talking about a series, I'm talking about adding up all the terms of that sequence and making it a sum. So I would say 4, not comma 7, but I'd say 4 plus 7 plus 10 plus 13. And I would add those guys all up together, and I believe they all add up to be 34. So the series of these terms in the sequence would be 34. That's the sum of all of the terms. Okay, just like last time, I'm going to give you a couple examples of different types of series, and then I'm going to give you the formulas and we'll refer back to these. So there's no recursive in this one, or not anything that we're dealing with at least. So the first one that we're going to deal with is arithmetic series. And so again, that's just the sum of the terms in an arithmetic sequence. My formula for this says S sub n equals n divided by 2 times a sub 1 plus a sub n. Let's talk about what these mean. S sub n is exactly how I was saying a sub n earlier. And this is, the S refers to the sum or the series kind of thing. And it's the sum of the first n terms. And again, it refers to the number of terms that there are. I know writing n and then drawing an arrow to say n is kind of counterintuitive. But if I say the sum of the first 5 terms, then this n would be 5. It's kind of hard to generally write about that number, so I just write n. If you hate it, write something else. A sub 1 is my first term, and then my a sub n is my nth term. Technically, in this formula, I don't need to know my d, my common difference, or the number that changes equally each time, or that you add or subtract each time to get to the next number. And then the next type of series is geometric series, which is the same idea. If it was a geometric sequence, then the geometric series would be the sum of the terms in this geometric sequence. This formula is a little bit different. It's kind of uglier. It goes S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. I don't know how in depth we're going to get in that. I don't think this is just a formula I'll put on your quiz or test. I don't need you to memorize this. It's not that deep. Uses the similar ideas of before, but I do use r here. So I need to know the first term. And I need to know like how many terms we're doing. I need to know what the n is. And then my r is my, common ratio, as we've done before. So if I'm, multiplying by 2 each time, I don't know why I said ratio, whatever. If I'm multiplying by 2, my r is 2. If I'm dividing by 3, my r is 1/3, those kind of things. So we just plug and chug if I ask you to find the sum of this many numbers in a geometric series, sequence, etc. Okay. So let's do some examples. I can give you some really basic ones. So very basically, I could just list out exactly the points that are in the formula and say, find the sum of this series. So that's what this first one's going to be. I would say, like, find the sum, and I would simply say A1 equals 17, A sub n equals 209, and n equals 25. I think I would have to tell you that it's an arithmetic sequence, or else we would not know which formula to use, so I'm going to tell you that. But other than that, I just gave you the exact terms that you needed. Plug and chug. If we want to keep up our color coordinating skills, which I love, We'll make this guy yellow, and we'll make this guy green. And so we're doing a yellow example now because it's an arithmetic sequence. So I'm going to do S sub n equals n divided by 2 times a sub 1 plus a sub n. Since this is right above me in my notes, I'm just going to erase these things and plug and chug what I know. I know n is 25, so I'm going to do s sub 25 equals 25 over 2. My a sub 1 is 17, and my a sub n is 209. If this is an even number out front, I like to divide that first. If not, then I like to do this and then simplify with the 2 and then multiply by that last number. You can just plug and chug in the calculator, but I like to do as much by hand. 25 over 2 times 226. Yep, you can simplify that. You're left with 113, and then 25 times 113 is going to be 2,825. Now, if I'm summing up 25 terms, you're going to get a big number. So maybe when we were doing sequences, we weren't necessarily getting bigger, crazy numbers, but here in series, we are going to get some really large numbers, and that's going to be okay answers. Okay. I could also do that with my R, with my, my geometric value. So we're going to do one of those. So I'm going to say an example, find sum, and I'm just going to give you some numbers to plug and chug. We'll say a sub 1 equals 2. We'll say R equals -3, and we'll say n equals 8. Again, I should probably give you that this is a geometric series, or it's from a geometric sequence, but what's one hint right off the bat that you know it's geometric? Easy, there's an R, right? There's no R's in arithmetic. It's geometric, so there's an R, but if we weren't astute enough, I would still tell you that. Again, use your formula. S of n equals, this time it goes a sub 1 times 1 minus r raised to the n over 1 minus r. So let's plug in. We know our n's are 8. And we know our a sub 1 is 2. And we know our r is -3. Ooh, it's important with this -3, throw some parentheses around there, or else you're gonna lose track of a negative and you're gonna get a sign wrong, and that can blow your whole problem up. Okay. Easiest thing to do first is -3 to the 8, and then also at the same step, I'm gonna simplify the denominator just because it's simple. 1 minus -3 to the 8. Oh, that's going to be a positive number. It is going to be a big number, but it's going to be a positive number. Positive 6,561 over, and then 1 minus -3 becomes 1 plus 3, which is 4. 2 times 1 minus 6,561 will be -6,560 over 4. You can simplify the inside here and then multiply by 2. Or what I would rather do is see that 2 and 4 have a common factor. That's going to be 2, and this is going to be 1. So then I'm just going to divide negative 6,560 by 2. And that's going to give me -3,280. And that's my S sub 8, my sum of the first 8 terms in this geometric series. All right. If you have any questions, let me know. Right now, we're just plugging and chugging. All right, the next example we're going to do is going to be along the same lines, but it's not just going to be as simple as a plug and chug. And let's make a new column for this. Let's make a straight line. There we go. Move this guy over a little bit. Ooh. Good enough. Okay. So this example, I'll write the directions and we'll see how it's different than the last one. I'm going to say find the sum of the first 40 terms of an arithmetic sequence Oh, series. I don't know why I said sequence there. Arithmetic series with 70 as the first term and common difference of negative 21. Whew, those were long directions. Okay. I know those are long, but we're given plenty of information here and enough to solve. I am told, first off, that it's what kind of series? An arithmetic. So I'm using the S sub n equals n minus divided by 2 n, words. S sub n equals n divided by 2 times a sub 1 plus a sub n. Okay, I'm going to use that formula. What part of that do I know? Okay, I know 70 is my first term, so my a sub 1 equals 70. I know, do I know my a sub n? Ooh, I don't know my a sub n. Oh, I do know my n though. I know my n is 40. And then the other piece of information they gave me, but it's not in my formula, my common difference is negative 21. Now, the reason I need my common difference here is I don't have a sub n. I need to find a sub n before I can plug into this. But given a sub 1 and n and d, I have plenty of information and I can easily find that value. I can easily do a sub n equals a sub 1 plus n minus 1 times d. That's why we did sequences first, so they can use that formula when I'm doing series if needed. I know a sub 1 is 70. I know d is negative 21. And I know n is 40. 40 and 40. Okay, so I'm going to start simplifying. 70 plus 39 times negative 21. 39 times negative 21 is 70 plus negative 819. And then you add those two together and you get negative 749. And that's a sub 40, okay? And I need to use that in there. So when I start solving this, I'm going to say S sub n equals n over 2 times a sub 1 plus a sub n. We know n equals 40. We know a sub 1 equals 70. And we just found out that a sub n equals negative 749. Okay, start simplifying. Since 40 divides by 2 easily, I'm going to make that 20, and then 70 plus negative 749 is going to be negative 679. Multiplied by 20, S sub 40 equals negative 13,580. Again, when we're adding all of these big numbers up, we may get a big crazy number, and that's okay. All right, so those are those formulas. I'm going to teach you one more. I'm not going to call it a formula. I'm going to call it a notation. I'm going to call it your summation notation. It kind of sounds like Schoolhouse Rock. Summation notation. Or we could call it sigma notation. Sigma is a letter in the which alphabet? Yes, the Greek alphabet. Those of you going to college soon will see that on College Row. Sigma is this E-looking letter, okay? I don't know why I'm writing in the middle like I'm a crazy person. All right, bring it to the side. Okay, sigma, this is a notation. It's just a way to express a sum using the Greek letter sigma, okay? So the notation goes, you have the letter sigma, and underneath it, we usually have n equals 1. That's your starting point. On top, you have some number. This time we're going to have, I don't know, 5. And then next to the sigma will be an expression. And the expression we'll use here is 2n minus 3. Okay. The n equals 1 is where you start. It's your starting point. You're going to start by putting n equals 1. We're going to put 1 in for the n. We're going to put it into this expression. This is your expression, or you can even think of it as your rule, like we had at the very beginning of our sequence lesson. And then the box on top tells us where we end. We're going to start with n equals 1, and we're going to add up each time until we get to 5. I don't know how many of you guys have done computer programming, but a lot of programs work like this. You can write a program where you like start at one number and then it like keeps looping until you hit another number. So it goes like 1, 2, 3, 4, 5, all the way until you tell it to stop. So this is kind of like a little computer program. Again, not sure if that's relevant to anybody, but I'm trying to connect some dots if anybody needs them. Okay, so we're going to start out, and I want you to think about, I'll just write it off next to it over here, I think. So we're going to start out plugging in n equals, we're going to go 1, 2, 3, 4, 5. We're going to go all the way up to 5. And underneath each of those n, we're going to have a new term. We're going to call it a sub n. For my first one, it's going to be 2 times 1 minus 3. 2 times 1 minus 3. Now, I'm going to be honest, I'm too lazy to write that out each time, so I'm not going to do that. We can just write each number. But basically what you're doing is you're erasing an n each time, and we're writing like times 1. And then the next time we're going to write times 2. And then we're going to build all the way up until we go times 5. If you need to write them out, please go ahead and do so. There is no shame in doing that. I just did not give myself enough space, and I do not feel like doing it right now. 2 times 1 minus 3 is going to be negative 1. Now, if I plug a 2 in, it's going to be 2 times 2, which is 4. 4 minus 3 is 1. Now plug a 3 in for the third one. 2 times 3 is 6. 6 minus 3 is 3. 4. 2 times 4 is 8. 8 minus 3 is 5. And then last is 5. 2 times 5 is 10. 10 minus 3 is 7. So we just made a list of all of those. Now we're doing the summation. So once we find all of the terms, then we're going to sum them together. Negative 1 plus 1 plus 3 plus 5 plus 7. We're going to add those together, and I believe they equal 15. That is what this is expressing. You do not necessarily have to show all work. You don't have to show work like this, but what you're doing is you're finding all of the numbers all the way up to what they equal. At bare minimum, you should have this. You should tell me which numbers you're adding together and what their total is. You can have a list of a line of going like 2 times 1 minus 3, 2 times 2 minus 3, 2 times 3 minus 3, etc., etc. But at bare minimum, I need this. All right, and so my answer would be 15. Okay, so we're going to do 2 more examples, and then we're going to be done with this stuff. Summation notation looks super scary, and so sometimes you guys see it and you flip out, and then you don't think about it and don't do it, blah, blah, blah. I want to try and show you a few examples so that you are not so scared of it in the future. So I've got a sigma, I've got n equals 1, my expression is 3n plus 7, and let's say we're going again to the 5th. Going much higher than 5 can be super annoying, so we probably don't often go up more than that. A lot of examples I give you will go up to like 7 or something because it just takes so much time. Okay, so I'm going to do 3 times 1 plus 7, 3 times 2 plus 7. Actually, let's make a little nicer list. Sometimes horizontal just goes on forever, so we'll do it vertical. 3 times 1 plus 7, 3 times 2 plus 7, 3 times 3 plus 7, 3 times 4 plus 7, and then last 3 times 5 plus 7. 3 times 1 plus 7 is 10, 6 plus 7 is 13, 9 plus 7 is 16, 12 plus 7 is 19, and 15 plus 7 is 22. Yep, I think so. All right, if we were to add those up, 3 plus 6 is 9, 9 plus 9 is 18, 18 plus 2 is 20. Oop, carry the 2. 2, 4, 6, 8, 80. Okay, it's as easy as doing it that way. Plug in, add them up, you're done. Another thing you can do is we can use our summation notation, or that's not at all what I wanted to say. We can use the formula that we had above. We can use S sub n equals n over 2 a sub 1 plus a sub n. Now, some of you may be asking, how do we know that it's an arithmetic and not a geometric? Well, first off, what are we doing inside of the formula? We're adding 7 each time. I know that you're multiplied by 3, but you're adding 7, you're adding 7. You can also go to your list and what are you doing each time? This time we're adding 3. So this is a simplified form of what we were doing. Remember, and I have all the notes together so I can go back and remind you. When we did our geometric sequence, we had a power. So if you're doing it by a power, you cannot do arithmetic method. That is a geometric sequence. But if I'm just adding and then have this multiply in front, that just means it's arithmetic. So you can automatically go to your arithmetic guy and solve from there. I do need to know my n. Well, my n is my ending number, which is 5. So I'm going to do s sub 5 equals 5 over 2. I do need to know my first number, so you need to plug in 1. So I'm going to do 3 times 1 plus 7, ignoring the fact that I already did it over there. That's going to be 10. And then we need to plug in the last number. So 3 times 5 plus 7 is going to be 22. So at bare minimum, you're just plugging in 2 of them instead of all of them, and then you're just using your formula. Again, I'm going to prove that you'll get the answer, whatever floats your boat. Perfect. Yep, that looks good. Yep, those are the same. So either method is fine. This is using summation notation to find a sum. We're going to do one more. This example says find the sum. And with my sigma, ooh, that's messy. I'm going up to 7 and my n equals 1. My expression is 40 minus I squared. Now this is not an arithmetic, but it's also not as pretty as the geometric one. So I'm just gonna do it using this method that we did over here, this like adding them all up, finding each term and adding them all up. You cannot plug it into the arithmetic formula. And I don't think it's the same as the geometric one either. So we're just going to add these up. If you want to try me and do the other one, go for it. But I'm going to tell you right now, this formula will not work for this because it's not an arithmetic sequence. Cannot vouch for the geometric one right now. So we're going to find all the terms. So I'm going to do, why are you not erasing? Okay. 40 minus 1 squared, 40 minus 2 squared. I like listing them so I know my journey before I get started. Going all the way to 7, right? I threw parentheses, not super necessary, but make sure that there's always a minus each time because we're not losing that. We're not squaring that. 40 minus 1 squared, well, 1 squared is 1. That's going to be 39. 2 squared is 4, so 40 minus 4 is 36. 3 squared is 9. 40 minus 9 is 31. 4 squared is 16. 40 minus 16 is 24. 40 minus 25 is 15. 6 squared is 36. 40 minus 36 is 4. And then 7 squared is 49. 40 minus 49, that's going to be a negative 9. It's okay to get a negative number. You can still find the sums. We add them all up. I'm going to be honest, I put in my calculator. I cheated because I didn't feel like doing mental math. And I got 140. And that ended nicely. That is the end of our series and sequences. If you need anything, let me know. Good luck with the homework. Come back if you need more help with any of these types of problems.